Let us solve an equation, a differential equation, under separation of variables, or under that solution, separation of variables. So let us consider the differential equation sin x, sin y, differential x, plus cosine x, cosine y, differential y, is equal to 0. So as you can see here, we have a function which is both in x and y multiplied to differential x, and another function also in x and y, differential y is equal to 0. So it says by definition under separation of variables that this equation is supposed to be simple enough so that by certain manipulations you can come up with a differential equation which is in the form a of x dx plus b of y dy. So what manipulation are we going to do? We will simply multiply here 1 over, as you can see, we multiply 1 over sin y cosine x, then the resulting differential equation is now sin x over cosine x dx plus cosine x cancels out in the second term, so cosine y dy over sin y is equal to 0. So as you can see here, we have now arrived in this form. We have sin x cosine x as our a of x, and cosine y sin over sin y as our b of y. So what are we are now the stage, or we're now in the step where we can now integrate. So we will simply apply here the integration formula du over u, which is equal to ln u plus c. So our u here in the first term is cosine, the differential is negative sine. So negative sine x dx over cosine x, and here our u is, the second term, our u is sine y, so the differential is cosine y dy over sine y. So it now fits this form, and let's go ahead and integrate. So negative ln cosine x plus ln sine y ln sine y. Let me erase that. Ln sine y is equal to c. Okay, so we can still simplify this. We apply laws for logarithm. So we have ln sine y over cosine x is equal to c, and if we will solve for for sine y over cosine x, it will be equal to e raised to c, and e raised to c is still a constant c. So the final answer would now be sin y is equal to c times cosine x.